Password, I think, because what is the password? I don't know. Why?
Sir Muthukumar, sir. Professor Muthukumar. Professor Muthukumar, sir. My voice ID audible. Okay. Professor Muthukumar, sir. Muthukumar, sir. I am audible.
Yes, sir, you are audible.
Good morning, everybody. Can you hear me? Good morning.
Good morning, sir.
Good morning, sir.
Good morning, Professor, sir.
Yes, sir. Yes, sir. Is it
Yeah.
audible?
Yes, sir. Yes, sir. Audible, sir.
Yes, sir. Yes, sir. Good morning.
Very good morning to the resource person and all the participants present over here. We welcome you all for the third day faculty development program on additive manufacturing technology. Hope you enjoyed the last 2 days. The first day we had the inauguration and we had Mr. Ligan Morgan from CAT Center who gave an overview on additive manufacturing and mechanical engineering. Then yesterday, Mr. Praveen Pandian, CEO of Evalve Lab, he gave us an overview on additive in mechanical engineering. And today we have with us Dr. V. Muthukumar, who is a professor with the Savitha Engineering College. Of course, he is with Mechanical Engineering Department. And he'll be giving a lecture on applications of additive manufacturing. And it's a vast subject. And given this opportunity, let me introduce today's resource person to you all. Dr. V. Muthukumar is working as professor in the Department of Mechanical Engineering, Savitha Engineering College, Chennai. He has completed his bachelor's degree in mechanical engineering from Alagappa Chettiar College of Engineering, Karaikudi, in the year 1998. Then he completed his master's from the same college from Anna University with first class. Then he received his doctorate degree from Anna University, Chennai in the year 2011. And he has got an expertise in the area of biomedical components, of course, 3D printing of biomedical components, composite materials, machining of composites, which is a very tough or unpredictable area to my knowledge. Then again, optimization, etc. Sir, to his credit, has got more than 22 years of teaching experience, out of which he was into research for 12 years. He has guided more than 12 PG projects and 50 UG projects during this tenure. He teaches kinematics of machinery, machine design, additive manufacturing, FEA, strength of materials, engineering mechanics, and engineering graphics. Sir has received the Best Participant Award and has been honored with 3D printed miniature model in the MHRD sponsored FDP on 3D printing in engineering education, organized by Department of Mechanical Engineering, NIT Warangal, during the year 2017. He has received Best Faculty of the Mechanical Engineering Department for the year 2009 to 10 and produced 100% results in many subjects. Dr. Muthukumar has published more than 20 research papers in international and national journals, and his research work has been presented in more than 25 international and national conferences. As I said, his core area is 3D printing of biomedical components and composite materials, machining of composites, and optimization, etc. Sir has delivered more than 50 guest lectures, including AICT sponsored FDP, STTP, then Anna University FDTP, and workshops organized from various reputed institutions. With this brief introduction, we from the Mechanical Engineering of Dr.M.G.R. Educational Research Institute welcome the eminent resource person, Dr. Muthukumar sir, and dear participants, we are going to hear an excellent lecture on the topic application of additive manufacturing from our resource person. And over to you, sir, Muthukumar sir, and the dais is yours. You can take over. Thank you.
Yes, sir. Very good morning, sir. So,
good morning, sir. We can hear you.
Sincere, yes, sir. My sincere thanks to our professor, Dr.M.G.R. sir, and the head of department, and the admin, and other faculty members, participants, for providing the opportunity to share my ideas with you regarding the topics, applications of additive manufacturing. My slide is visible, sir?
Sir, yes,
hello.
Sir.
Thank you, sir. So, today I am going to describe or explain some of the applications of additive manufacturing in this FDP program. In our college, we have some additive manufacturing facilities. We have some machines in FDM kind of thing, some composite printer and the SLA machines. So I will proceed. Why we go for additive manufacturing? Because in this slide we can able to see here the evolution or of the industrial evolution, that means from the first industrial revolution, the mainly the water and steam power is considered.
Sir, we understand there was some network issue from your side, and it was things were still. Dr. Muthukumar, sir, can you hear us? Sir, I think there was some network issue from sir, whatever that you have delivered, till now, maybe for the past few minutes, we could not hear, sir. Can you please repeat it again, sir? Can you start from the scratch? Sir, I think you are muted. You can unmute yourself, sir.
Yes, sir. Now slide is visible, right?
Yeah, now slide is visible. You are also audible, sir. Can you please
Yes, sir.
start from the start?
Yeah.
Yes.
So why additive manufacturing is important? So now we are in industrial 4.0. Mainly we concentrate on cyber physical systems and other 9 technological pillars as indicated in industry 4.0. One of the technology in mechanical engineering, we are mainly concentrating on 3D printing or additive manufacturing. I am moving the second slide. So this is the actual the video.
It's hard to deny how far 3D printing has come.
So
Once thought of as
now
a
we
niche
find
hobby
lot
for
of
enthusiasts
applications
or an industrial tool, additive
in
manufacturing
additive
is
manufacturing.
now more accessible than ever. From simple FDM devices that extrude thermoplastic layer by layer to PolyJet 3D printers that can achieve a silky smooth finish and amazing details, there is no limit to what 3D printing can do. But for some people, even that was not enough. They had to push the boundaries of technology and invent an entirely new method of cooking. In all their ceaseless wisdom, they took a look at it and said, what if instead of PLA, it was cheese? And whoever came up with it has something promising on their hands. When you see a food 3D printer,
So this video briefly gives the summarizes
in its early
the
stage, I don't know what to
applications
do
of
with yet.
3D printing in various fields.
It can be used to cut down eating habits. Let's say, and this is already coming. Or home if they become more
So
affordable.
I will move
It's
to
hard to deny.
next slide. So what do you mean the 3D printing? So this is the simple inkjet printer in 2 dimensions, black and white. We are doing normally in day-to-day life. If we want the color print, we will go with some printer with colored version. Now, this particular slide gives the idea about the 3D printing. So we are adding the three-dimensional thing layer by layer in additive manufacturing. So what is the definition? As per ASTM standard, the 3D printing or additive manufacturing is a process of joining materials to make objects from three-dimensional model data, usually layer upon layer, as opposed to subtractive manufacturing method. So here, very important thing is we will provide the input model. So we need some three-dimensional model. Then we have some softwares we can do some slicing operations and support structure generation, all those things. Then we can feed it to the machine as in G-code form. Then the printing will happen as seen in this particular video, layer by layer, you will get the final object. So this is nothing but the 3D printing or additive manufacturing process definition. We have various terminologies. Now people are talking about the 3D printing with some other names as well. 3D printing or additive manufacturing, then layer manufacturing, solid freeform fabrications, digital manufacturing, then rapid prototyping or rapid tooling, all those things comes under the name of this additive manufacturing. Now we can able to see here what is the main difference between the traditional manufacturing versus additive manufacturing or subtractive manufacturing versus additive manufacturing. In this, the first video, we can see how this the traditional manufacturing will happen to make the objects as this craftsman will do for creating the 3D structure. In the bottom, we have the 3D printer. Now we are adding the material layer by layer, as similar to the machine will do in the construction work. This is nothing but the very good example you can able to see for 3D printing or additive manufacturing. So why we go for this additive manufacturing? It is the next slide. Now in the first row, we can able to see how much material is required for making this three-dimensional object, and the wastage is this much quantity in subtractive manufacturing. Now we go with the additive manufacturing. We can able to see the material is given in some raw material, maybe a less amount only we will provide, and the wastage is very small as compared with the subtractive manufacturing process for the same component. This is the very good advantage we have in 3D printing. Now, generic classification of 3D printing process as per ASTM standard. Generally, the 3D printing process are classified based on the material and as well as in the process involved for converting the given raw material into the final product. So the given material is in the form of liquid. Then we have the two technologies. One is wet photopolymerization. In general, we call it as SLA, stereolithography apparatus. Another type is material jetting. It is also the liquid resin is given as the input material. Second one is molten or filament process, in which the raw material in filament form or wired form. We can use the term called as material extrusion process. The great example is FDM. Third thing, we have used the powder process, in which it comes under three types or three categories. One is powder fed fusion, in which we can use both polymer as well as the metal powders. Then binder jetting, this is also the powder based process. Here also we can use the ceramic material and powder and polymer powders for doing this additive manufacturing. Third one is the direct energy deposit. Here also the metal powders and the wire are used for as the raw material. Final one is the solid layer process, in which we can provide the seeds as the input material, solid seeds. So it is called as the seed lamination process. So we can find there are 7 types of additive manufacturing
Additive
process.
manufacturing is one of the major
Now we
advancements of
can
Industry
explain
4.0. It is
in this
comprised of several different
particular
processes.
video. We can able to see. So how the design will happen. This is the first stage in 3D printing process. The first stage is we can
Created
go
design
with
software
design
or CAD
by using
selecting
some
an
of the
existing
software.
design through libraries
We
or
can
by
get some
scanning an existing
libraries
part
from
with
the
3D
existing.
scanning. Each of these methods will then take the 3D model and create an STL file. The STL file is then transferred to slicing software, which preps the model for the final printing stage. The model is sliced into layers, and a path will be generated that the printer can understand. A variety of parameters can be adjusted during this stage. Manufacturing begins through one of the 3D printing processes. In each process, material is added layer by layer. In additive manufacturing, you're only using the materials that are needed, compared to some traditional manufacturing methods where the material is removed and scrapped. The materials utilized in additive manufacturing are vast, from metals to sand and concrete to human tissue. Let's take a look at each process and which materials each supports.
Binder jetting printing process works by applying a liquid bonding agent to a powdered material. First, powdered material, either plastic, metal, glass, sand, or
This particular video gives the short explanations for all 7 processes how the 3D printing happen. The input is the 3D model, then we will go with some STL file conversion, then slicing. After that,
ceramic
how
is
the
rolled out
process
in a
will
thin
happen.
layer. The print head then applies the binder to the areas of the powdered material that will become the final part. The build platform is lowered, and the entire surface is recoated with fresh powder. This process is repeated again and again to build up parts layer by layer. After the printing process is complete, the loose powder is removed, and a 3D printed part is extracted. Directed energy deposition, also known as DED, is essentially a form of build-up welding. The material, either in powder or wire form, is melted by an energy source while it's being deposited. The process repeats with each layer adhering to the underlying layer. The energy source can be generated from a laser, electron beam, electron arc, or plasma. Directed energy deposition can make new parts, add features, or repair existing parts. Material extrusion works similar to a hot glue gun, where glue is heated and squeezed out as a liquid. For material extrusion, A filament or pellet material is heated and extruded through a nozzle and deposited onto a build platform, layer by layer. In more sophisticated systems, additional extruders can apply different materials within the same build, with one material acting as a support structure. The capabilities of material extrusion are diverse, ranging from consumer plastics to aerospace titanium. Material jetting uses a process and equipment similar to inkjet printing, but instead of dropping ink, the printhead selectively deposits droplets of material onto the platform. An energy source, such as a UV light, is then used to cure the layer before dispensing the next layer. This process excels at producing parts and assemblies with excellent detail and a relatively smooth surface finish. Parts can be full color or have multiple types of material. Recent improvements in materials have led to its adoption for indirect and direct production of functional components. Powder bed fusion is a process where powder material is spread and a thermal energy source, such as a laser or electron beam, selectively fuses regions of the build area. The build box is lowered and the powder is recoated, continuing the process layer by layer. For polymer material, the powder surrounding the part acts as a support, enabling the production of complex shapes and fine details. Sheet lamination, just like its name indicates, is a process where sheets of material are stacked. The boundary of the layer is bonded together to form an object. The sheet lamination process has many forms and can utilize a wide variety of materials, such as paper, polymers, and metals, along with numerous methods of bonding the layers of material. These bonding methods include adhesives, chemical, heat, and solid-state welding processes, such as ultrasonic consolidation. That photopolymerization gets its name from its original form of using a large vat of liquid photopolymer resin, or liquid plastic, which solidifies when exposed to a strong light source. The light source selectively cures a layer of the liquid material, and the platform and part move together to let uncured material coat the next level. That polymerization is typically regarded to be the highest resolution AM process and is capable of producing parts with extraordinarily fine details.
These advanced manufacturing techniques are just scratching the surface of what's possible. Additive manufacturing.
So the last video is the self-explanatory of all 7 types of 3D printing or additive manufacturing process. Here, comparatively, I am giving this particular slide for understanding the principles, diagram, everything. Considering these various parameters, we can select which machine is used for our particular applications. Now, the commercially available materials will be indicated in the first row of this comparison table. In which powder bed fusion, we can go with either polymer or metals. Directed energy deposition only use metals as the input material. In material jetting process, we go with polymers and ceramics, sometimes the metals as well. Binder jetting, we go with metals and ceramics. Material
Sir, you are not audible, sir. I think there's some communication, network issue. Sir, Muthukumar sir, I think there was some network issue. Dear participants, sorry for the interruption. Sorry for the disturbance. It has happened due to technical glitch.
Yes, sir.
Yeah. From that 13:13.
Yes, sir. No, it's okay, sir. Yeah. Hello.
Yes, sir. You can go to full screen, sir, please.
Yes. This slide is already we discussed, right?
Yes, sir. Partially, halfway through, yeah, from
Yeah,
that,
yeah.
it got disconnected. Sorry, sir. Yes.
Okay, okay. No issues. Yeah. Here, considering the printing cost, we can select the machine of low cost printing will be material extrusion and sheet lamination process, and medium level the binder jetting and the wet photopolymerization, but relatively high cost in powder bed fusion, direct energy deposition and material jetting. Considering the accuracy as the main importance, then we go with the material jetting process, first option. Second, medium level, we consider this powder bed, binder jetting, and sheet lamination, wet photopolymerization, but very low accuracy in material extrusion as well as in TED process. This particular video will give the idea about the normally using the technology, that is the material jetting process. This is the machine FDM, fused deposition modeling, that is given by the company name, but scientifically we call this the material extrusion process. Here the material is extruded from the nozzle, heated nozzle. Here the input material is the filament. There may be two filaments. Here we give as input, one for the model, another one for the support structure. So there are sometimes we go with the dual extruder as well. This is the flow of the filament in this particular FDM process, and in the extruder portion, heated. These are the some uh, nozzles through which the material will be extruded like this. So now we can see here there is the two material. One is the white color, which acts as the support material, and the black color, it is the actual model material. Why we can go with the same material, or sometimes we go specifically the different materials or different colors also possible. So this is the final model we have printed in FDP process. Then we have some cutting tools for removing the support structures, and we go with some post processing process. We can clean and remove the excess material or unwanted materials. So, there is, we can go with a lot of components manufactured with the MDM process. Generally, it gives the low accuracy. Then we go with for rapid prototyping or model making. So this idea gives the FDM process how it works. Now we come into the new slide, next slide. In any 3D printing process, it involves three stages. First is pre-processing, second one is processing or fabrication, third one is post-processing. So pre-processing consists of we can create the 3D model in different input way. So how for making the 3D model we can go with some specialized software. In the bottom diagram, we can able to see there are the three methods from which we will get the 3D model. One is the 3D scanning technique. So if we will get some medical images in DICOM file from the CD scan or MRI scan. So that process we get the DICOM images, we can convert into the STL file, then we provide us the input. Second one is directly we go with some softwares like Creo or Fusion 360 or KTR. Then we will create some model. That is the direct 3D model creation. Another one technique is photo scanning, in which we have the some 3D scanner or photo scanners. So it will take the 360-degree of the entire product. For example, we call this the reverse engineering technique, in which we will convert into the STL file. So after creating the STL file, then we go with the slicing. Slicing is nothing but now the peoples will do in our house. Our mom will do the valaka bhaji and all. So the slicing, how the 3D surface is cut into the two-dimensional layers. That is the slicing, for which some softwares are used, mainly this Cura. That is the one of the open source free software. It is available. It will slice the entire thing. After that, we can go with some support structure based on our input. Uh, we will go with some part orientation and all. Then we convert into G code. You can see the right top here after slicer or Jura software. Then we will go with some coding. Already we studied in CNC, that is G code or the M code. It gives the X, Y, and Z direction movements. Coordinate values will be given. Some operations are also automatically generated by using this Cura software. Then it is converted, it will be copied and given as input to this printer in right side bottom. Then the green color is the material, then printing will happen. This is the process we call as the second stage. Third stage, after removing the material or component from the 3D printer, we go with some powder process. The process may be the removal of the powder, or heating or curing, heat treatment, or metal infiltrations. Lot of process based on our application and material use. We go with some post processing method. So in general, there are three stages in 3D printing or additive manufacturing. One is the pre-processing, that is nothing but model creation and the generation of the G code. Second one is fabrication of the particular model in 3D printer. Third one is the post-process. These are the important steps involved in this 3D printing process. Again, you can see here general flow of this particular process. Creation of the CAD file, then convert into the XT file. Then slicing, support generation, and selection of process. Lot of research the people are doing in this 3D printing area in selection of process parameters for the new materials. Or slicing also, we have the adaptive slicing. We have some algorithms. So we can go with some new algorithm development. And support generations, it's also very important. Now the people are doing the support generation by tilting uh, or changing the orientations. Then this is the 3D printing process. Then removal of part, support structure removal, and post process. This entire flow, we will understand how the 3D printing will work. This slide gives some idea about the 3D printing materials. Mainly, we classify the materials into the plastics and metals. So thermoplastic as well as the thermostatic plastics, both will nowadays possible to use in 3D printing. The input material may be in SLA or VAT photopolymerization or material jetting. We can use this. Resin is the input material, the polymerization, liquid form. Some other easily available low cost material is PLA, polylactic acid, is the biodegradable material. So normally the people will use this PLA material for biomedical application as well. Then ABS, this is the somewhat it has higher strength compared with the PLA. Similarly, you go with the PEI, ASA, and TPU. These are the some materials. Nowadays, nylon finds a lot of applications in 3D printing. And also we have the plastic filament with fillings. This is nothing but we can go with some fiber placement inside this filament material for PLA for improving the strength. So we call this the composite materials. It is also find a lot of scopes in doing the research. Coming into the metals, we find the metal machines, but the cost for the machine is higher when we go with metal machines. So approximately 1.5 crore to 3 crore for this material powder bed fusion, or we go with this DED process. The material may be the titanium, cobalt, chrome, stainless steel, aluminum, or nickel. So this particular slide gives some idea about the material used in 3D printing process. So we find some important advantages of 3D printing. Why we go with 3D printer or additive manufacturing? It is the question. First one is design freedom and complexity. Any complex structures will be 3D printed, but it will not possible. Any complex or intricate components will not be manufactured using the subtractive process like milling or CNC, all those things. Now we go with the 3D printing with custom shaped objects. Rapid prototyping. So quickly we can produce the concept models. Then reduce the material waste. compared with the traditional subtractive process. Customization and personalization. So for healthcare industries, mainly when we want to make some prosthetics or implant, so we go with this 3D printing process. And on-demand manufacturing. It eliminates the inventory cost as well. So we can go with 3D printing whenever it is needed. So the complex assemblies and the consolidation, this is the another main advantage. So the consolidation of, we can reduce the number of components. For example, if the particular engine has the approximately 300 component means, we can make into 8 components or 10 components by using this consolidation process. The fast iteration and prototyping is possible. Reduced lead time, that's also the important advantage. And any complex structure will be 3D printed. Remote and on-site production, this also the important need nowadays. And the education and the research purpose, a lot of peoples or students or researchers using the 3D printing for the experimentation and also in prototyping. Future, we will go with some sustainable materials. There is some issues in the material, so we can reduce the material waste, or we can go with the waste materials is recycled and make as the new material for attaining the sustainable goals. So this particular video gives a lot of applications we have in additive manufacturing. It starts from 3D printing of house and bike. This right side we have bike, it is fully 3D printed, boat and car. So we have a lot of applications. It is listed here. It starts with the automotive industries, aerospace, manufacturing and tooling, that is the five industries, then medical applications, then architectural applications, jewelries, and creating the miniatures, and the music, film, fashion industries, food printing, museum displays, space. These are the some specific applications. So why we need additive manufacturing is mainly it started for making prototype. This additive manufacturing is developed for making the prototype models. That is the first applications. So we can see that if a picture is a worth of 1,000 words, but the prototype is a worth of 1,000 pictures. So we can make the 3D model, that is very important for understanding the ideas or concept of the new product. Now we can take this particular example for making the prototype model for presentation. So we can make the miniature model of this particular car. This is for your comparison. Then we will make some fit function and assembly models, mainly with the IC engine. You can see the piston and the connecting rod and the crankshaft assembly in single cylinder as well as in the multi-cylinder engines. It is also we can make as a prototype model. Sometimes we go with direct part production in automotive industries. So this is the first 3D printed car in the globe, and we have the some intake and the exhaust manifold. That's also 3D printed by using suitable technology. Then we can directly use for these applications. These are the some other applications related with this prototyping. Next application is in aerospace. Mainly, why we use this 3D printing technology in aerospace is main thing is weight reductions. You can see the right side diagram. The aircraft, the original model weighs 3.05 tons. After going with some topological optimization, that means we can remove the redundant, unwanted material using the lattice structure concept, so that we reduce the weight of the flight. So we can reduce 40 or 50% of the weight. Second important of 3D printing in aerospace is part count reductions. So the functional
Sir, I think again some network issues, sir.
sorry sir again
Yeah, it's okay, sir. You okay? Please continue, sir. No problem.
yes sir. So I am in this particular slide.
Yeah, from seventh slide, sir, like the 3D
Yeah,
printing in aerospace.
yeah. So here in this particular injector head, actually it has the 248 individual components. By using this additive manufacturing technology, we can integrate into the single one. So automatically the 50% of the cost is reduced and assembly line cost also reduced, assembly time is reduced. So it has 3 times faster production is the main advantage in aerospace sectors. These are some components, engine, combustion chamber, some other parts directly we can print using these technologies. In ISRO also, now the it is tie up with the Wipro, they 3D printed one cluster. That is the first additive manufacturing engineering component for ISRO. This is the part of the GSAT-19 satellite. This is the first air product used by ISRO to fly. The part is being called as feed cluster. Here also you can see here the feed cluster. In order to reduce the lighter weight and the customization, so we can make us the single part. There is the specific applications of this 3D printing used in ASR. Now we have one audio video clip
சென்னை
here
ஐஐடியின் வடிவமைத்துள்ள ராக்கெட் விரைவில்
in
விண்ணில்
Tamil. Voice, you are getting audio from this particular video. Is it, sir?
விரைவில்
Yes,
விண்ணில்
sir. Yes, sir.
Yes, sir.
சில ஆண்டுகளாக இந்தியாவின் ஸ்டார்ட் அப் நிறுவனங்கள் பல்வேறு துறைகளில் ஈடுபட்டு உலகின் கவனத்தை ஈர்த்து வருகின்றன. அதனை மெய்ப்பிக்கும் வகையில் அமைந்துள்ளது சென்னை ஐஐடி மாணவர்களின் ஸ்டார்ட் அப் நிறுவனமான அக்னிகுள் தயாரித்துள்ள அக்னிபேன் ராக்கெட். தற்போதைய நிலையில் நம் நாட்டில் இஸ்ரோவின் ராக்கெட்டுகள் மூலமாக பெரிய அளவிலான சேட்டலைட்டுகள் மட்டும் விண்ணில் ஏவப்படுகின்றன. அக்னிபான் ராக்கெட் மூலம் சிறிய அளவிலான சேட்டலைட்டுகளை விண்ணில் செலுத்த முடியும். அக்னிபான் ராக்கெட் மூலமாக 30 கிலோ முதல் 300 கிலோ எடை வரையிலான செயற்கைக்கோள்களை ஏவி விண்ணில் 500 முதல் 700 கிலோமீட்டர் தொலைவில் பூமியின் கீழ் புவிவட்ட பாதையில் நிலைநிறுத்த முடியும். இதனால் விண்வெளித்துறையில் எதிர்காலத்தில் பல்வேறு மாற்றங்கள் நிகழும் என்று நம்பிக்கை தெரிவிக்கிறார் அக்னிபான் ராக்கெட் வடிவமைப்பில் ஈடுபட்டுள்ள பொறியாளர் சரண்யா.
பெரிய பெரிய சேட்டலைட் தான் கொண்டு போகுது. இப்போ நாங்கள் வர்றதுனால சின்ன சின்ன பிளேயர்ஸ்க்கும் ஹெல்ப்ஃபுல் ஆகும். ஸோ அந்த கம்யூனிகேஷன் வைஸ் அதெல்லாம் இன்னும் இம்ப்ரூவ் ஆகும். இன்டர்நெட் வகைரா அதெல்லாம் நிறையா சேட்டலைட் சின்ன சின்ன எக்ஸ்பெரிமெண்ட்ஸ் பீப்புள் டூ.
So this particular rocket was developed by startup in IIT Madras Research Park. Now they developed and launched by ISRO recently. Last week it was launched.
சென்னை ஐஐடியின் ஸ்டார்ட்.
So this is some other applications of 3D printing in space. The peoples will take the small 3D printer for making some customized parts for their requirement. Now we see this another video
to go to the moon today, and you want to go there to be
for making this space applications. So some of the parts.
That's a very interesting concept, because by doing this, you protect the astronauts from the two main threats they have on the moon's surface, that is solar radiations and micrometeorites. Now, let's bring back this concept to Earth. What could we do with this? We want to use a solar oven. So, like using the sun, having a lens, and space station they needed. On we got an answer was just no, throw it away. That's why Mother Nature, weight is amazing, is half of it.
Because we want to reduce the weight for aerospace. So here the latest structure or topology optimization.
Everything away. It's so complex that you have to have bolts as a weld can fail. Here is done in one piece. Few hours manufacturing time, days manufacturing time. Weight is amazing, is half of it. But yet, the ideal is not yet there. What we needed to do is this. This is what we call the bionic design. This is how Mother Nature would build it, meaning it's putting material where the loads are. On another bionic design, time ago, we were about to test it, and it was so different that the company who built it, not this one, another one, they didn't want to test it. They didn't even want to manufacture it because it felt so strange. They said, no, we are afraid of this. Actually, I remember a colleague of mine saying to me that this is asymmetric. Well, forget about symmetry. Mother Nature is not symmetric. You are not symmetrical. So now,
similarly,
3D printing,
for 3D printing, we can go with making
the red area is meaning where all the.
This is the implant, bone implant, hip implant. It is also made of this lattice structure.
For playing squash.
Possible by using this.
So now put on a spacecraft. As simplify this part.
So you find the lot of applications for making the
drawings. You can even the kidney. So it does what
for
the
making
does.
some livers and all.
To to the moon, remember the dream.
So, and also in further extensions, the 3D printing
That I've
is
been working on recently.
the
They're doing
for
the drone.
making the
It's
drone.
about 12 inches in both the X and Y
Now, a lot
direction,
of
and about 4 inches tall.
scope in
So we're
the
gonna load this
drone
up in
industries
GrabCAD and
in
start over.
future.
The
Now,
drone
how
loaded
it
into
starts
GrabCAD,
with the
we're going to separate
printing.
the bodies from the assembly. Once we've done this, we're going to orient the part. We're going to select the face, and then we're going to hit bottom. Then after we've done this, we're going to hit arrange. We're going to move the purging tower into the corner, the drone next to it, and then the lid. Once we've arranged all this, we're going to now slice it. With the slicing complete,
These are
we'll
the
now have
steps
an
in
estimate of how
the
long the
CAD
print will
model
take.
for
It'll take
creating
about a
the
day
new
long.
thing
It's
and
about 25
slicing.
cubic inches, and that sounds
This is the
about right.
simulation in
We're now
slicing
going to have a look
software.
at the slice preview.
You can see the
As we scan
every
the
layer
layers,
how
we
it
can see
is
that nothing sticks out
printing.
and everything looks good to go. So we're going to go ahead and start this print up. Now we've hit print, and it's going to send it over to the printer, and then we're going to start it there. Before we can start a print, we're going to have to load a tray into the printer. So we're going to grab one, we'll place it, and then we're going to press it down, and then lift the lever to secure it. Then we're going to close the door, and go ahead and start the print.
Now the material is ready. Print will start.
Now that we started this print, I hope you enjoyed this time lapse that I made.
Now the printing is happened in this particular way. So how the drone is 3D printed using this particular technologies.
With the print complete, it's time to remove it from the printer.
After
To
that,
do
we
this,
can
we're gonna start
remove
with
the
opening up
print,
the door,
then
and then
process.
we're going to press down the lever
Post
and lift
process.
the platter out.
We can see the
Everything
model
looks
is
great on the
designed
printer, so
and
we're going to
3D
take this over
printed.
to the table, take everything off the plate. To remove the prints, we're going to start with bending the build plate and then peeling this print from it.
The bottom black color is the
We're going to do
builder
this for
plate.
both the
We
prints.
can move.
And then once
And
we've done this, we're going to take it over to the
these
ultrasonic bath
white color things
and
are
dissolve off the
support
support
structures.
material.
We can remove these support structures. We get the.
Removing the support material
This
is
is
a very
the
easy process. Place
post
the parts
processing
into the
process.
ultrasonic bath. Then we're going to place the grating on top. Once we've done this, we're going to close the lid, and then we're going
This
to
Sir, again, network issue, sir.
Sorry, sir. Again, I have issue here in network. Now this slide is visible. Is it, sir? Sorry.
Yes, sir. Yes, sir. Please proceed.
Yes, sir. Yes. Now the next application is mainly for making the tooling or manufacturing related thing. If you want to make this kind of spark plug or the water bottle, some kind of this models, we go with some tooling or molding kind of thing. It is also done by using this 3D printing or additive manufacturing. Now the Pepsi company, they will make the hybrid 3D printing process to make flow mold for their bottles. As you can see in the top, that model is also 3D printed.
Here is our blow mold section.
This is the flow model.
Is creating new
It is
bottles that
3D printed by using
this
this.
that capture the bottle geometry. These were made on a high-speed photopolymer 3D printer from Nexa 3D. They use Henkel Loctite X Peak material, and these sections go into a standard size blow mold shell, and that shell is made of steel. That hybrid tool results in a blow mold that can be created within 48 hours. And a recent blow mold that PepsiCo made this way to test a new bottle, it produced 14,000 bottles, and it's still going.
So we can make this kind of the mold for making these bottles. As per this video, he explained he used 48 hours for making this models, right? There is some other applications extended in this particular thing, making the master mold and all. Sometimes we can go with making the patterns as well by using the 3D printing process. And the main application is in medical field. So how the 3D printing or additive manufacturing is helpful in the 3D printing medical applications. First one, for making the surgical models, for planning their operations, pre-operative, and for making some intra-operative guides. So this is the first applications. Second one is education models in medical college. For they will make some demo models for patient educations and learner educations, and also the some simulation applications, and also for making the medical devices, for example prosthetics or wearable devices and implants. There may be the permanent implant or bioresorbable implant. These things also done using 3D printing. And the tissue engineering. Now latest thing is we can print the scaffold based tissues, and bioprinting is the latest applications. Now even now we can able to print our liver, heart, skin, everything by using this bioprinting technology. So entire body is 3D printed. Everything you can see here in the starts from the top, 3D printing of skull. Lot of accident cases happen, the skull removal process, some were damaged in the top. It will be 3D printed and it will be used for doing the surgery, and 3D printing of the scapula here, and 3D printing of acetabular bone here, and 3D printing of knee joint, and 3D printing of and the part of that is the femur bone, and spin, 3D printing of spin, and 3D printing of sternum in this area, and 3D printing of lower jaw. That is the dental applications. So entire body we can use the 3D printing. Sometimes we used in COVID-19 for 3D printing applications. Lot of applications that people use this our 3D printing technologies for making the hands-free handle for opening the door and all, and the swabs for testing the COVID positive or negative of the things. Then the face masks may very much useful for the doctors and the nurses and the ventilators. In the second COVID time, there is a demand for the ventilators at the time. This technology only helpful for making these ventilators. And nowadays it is possible to create some art models like this. We can go with this particular video here. There is a one machine. This is the Form 3B machine, SLA type machine. Here the input material is resin or liquid, mainly used for dental applications. Also, this is a Farm Lab product. You can able to see here.
The possibility of dentistry rate the days of depression.
So
Having a 3D
similar
printer in
kind
my
of
practice
lot
has
of models will
things
be
with it,
3D
including
printed.
making my own bleaching trays, bite guards, or even surgical guides. Precision 3D planning procedure on that 3D printed model. So that way when I go to the mouth,
Here you can able to see here after making this kind of the mandible here we go with some drilling and guide this the surgical guide. That's also possible. It helpful for the doctor surgeons doing this
the amazing thing
dental
like
implants.
printer, but it won't make us change what we do.
Next development in medical 3D
அதை
printing is
சாத்தியமாக்கத்தான் மீட்டோ பிளஸ் என்ற 3D பயோ பிரிண்டரை
in
உருவாக்கி வருவதாக
Chennai itself. Some company they have
தெரிவிக்கிறது
developed
சென்னையில்
some
உள்ள
bio
அவே பயோ
printer.
சயின்சஸ் என்ற நிறுவனம்.
This is the bio printer.
பயோ 3D printer பண்றோம். ஒரு தேவைப்படுற டிஷ்யூவோ இல்ல ஆர்கனோ அதுக்கான ஸ்கெஃபோல்டிங்கை வந்து நம்ம பிரிண்ட் பண்றோம். இப்போ ஸ்கெஃபோல்டிங்கிறது ஒரு வீடு மாதிரி. இப்போ வீடு கட்டுறதுக்கு என்ன யூஸ் பண்றோம்? ஒரு பிரிக், சிமெண்ட் அது மாதிரி யூஸ் பண்றோம். அது மாதிரியான ஒரு மெட்டீரியல், அந்த மெட்டீரியல் நம்ம வந்து பயோ மெட்டீரியல்னு சொல்றோம். ஸோ இந்த பயோ ஸ்கெஃபோல்டிங்குள்ளார நம்ம தேவையான செல்ஸை வந்து இன்டியூஸ் பண்ணுவோம். இந்த 10 ml ஆஃப் செல்ஸ் இந்த பயோ மெட்டீரியல்ஸை வச்சு மல்டிப்ளை ஆகணும். இப்போ இந்த இன்குபேஷன் ரிசல்ட்டை வச்சு தான் இந்த டிஷ்யூ சக்ஸஸ்ஃபுல்லா இல்லை ஃபெயிலியரா அப்படிங்கிறது தெரியும். இப்போ செல் க்ரோத் வந்து அபோவ் 90% இருக்குன்னு வச்சுக்கோங்களேன். இப்போ அந்த டிஷ்யூ வந்து சக்ஸஸ்ஃபுல் டிஷ்யூவா வந்துருக்கு நம்ம கையில் இருக்கு. இப்போ இந்த மாதிரி ரிப்பீட் பண்ணி ஒரு ப்ராடக்ட்னா அந்த லெவலுக்கு போயிட்டாங்க. ஆர்கன் டிரான்ஸ்ஃபர் செல் லைன் ஆர்கன் ப்ரிப்பேர் பண்ணும்போது கிடைக்கும்.
எங்களை அணுகினார்கள். எங்களது பயோ பிரிண்ட் வைத்து நாங்கள் ஒரு மீன்
கம்மி அது போக தான் இருக்கும். அதுக்கு பண்ணிட்டு அது மேல டெஸ்ட் பண்றது இன்னும் எஃபிஷியன்ட்டா இருக்கும்.
This printer is approximately 12 lakhs, I think so. So it can be used for making some biological models applications. Bioprinting of livers, skin, everything is possible. Then we have the other applications in medical 3D printing. This is the first time we can print the heart. Now the heart is also 3D printed. It is the very useful thing. So
It is
based on a small biopsy that is taken from a patient. The cells and the biomaterial from this tissue are separated. The cells are reprogrammed to become stem cells and then differentiated to become cardiac cells and cells that form blood vessels.
This machine is FDM based, fused deposition modeling. Instead of the filament, here we are using the cell ink or bio ink, that is the input material for this application.
And the biomaterial, the collagen and the other sugars that in the tissue is processed to become a bioink, and together when mixed, we have bioinks for the heart and bioinks for the blood vessels. And then we use a 3D printer to print whole hearts with the major blood vessels.
I'm not sure it's going to serve ourselves in the next few years, but for our children, I think it's going to be maybe an amazing opportunity.
The whole process may take months or two from the minute that we take the biopsy from the patient till we create the cells and print them. And the next stage is to mature these hearts in the lab for at least a month to help the cells or teach them how to interact with ability to land them.
A small size though, but we are very optimistic.
This is the first time.
Some other applications. Why we go with the 3D printing in medical industry? One is customization and personalization. That means tailored to a patient-specific anatomy. Because as a human being, we have the anatomy structure is different, so we can go with the customized one. But the complexity, that is for a bone or porous metals, all those things we can print. Any complex structures is 3D printed. So cost wise, no expensive tooling. Reduced waste makes this a affordable price. The lead time is much faster than traditional methods. So the specific 3D printed implant. Now we can see this implant. There may be some tumor in this particular patient. So how we go with this patient specific implant?
Sir, some network issue, sir.
Sorry, sir. Again.
Okay, sir.
Yes. So this 3D printed implant we will Similarly, how we convert the CD scanned images, whatever we get from the model. Here we have some software called as 3D Slicer. It will convert the medical model into the 3D model. This particular software, from which we convert very easily. So how these are nothing but front view, top view, and three-dimensional view, and this is the final 3D model. So, from CD images or MRI images, we can make these three views by using this particular software. Then we create this is the final 3D model.
This is like if you want to see, yeah, no, color no, like but I will need this between us.
We can do some process for converting this into the phony structure, right?
Now I have to work.
We
like
can adjust or cut or remove, select, anything is possible. Segmentation is also possible.
Let's say for this day.
So this is the actual conversion process, how we convert.
But I will convert that into.
Yeah, this is the final model, CAD file model. Then we convert into the STL file. Then we give us the input to the 3D printer. We can print. This is the idea. And 3D printing of some bones for the surgery applications, how they created here after creation of this particular model, then how the 3D printing is happened, right? It can able to see here. It is a SLA type process, right? Stereolithography. The input material is resin. Here we can go with some laser kind of UV light frames. Now the bone is 3D printed, whatever we done. So here you see this bottom thing is the support structure. This is our final model. It is 3D printed. Then we can remove the unwanted thing. We can use some PVA solutions for cleaning. Now we got this particular structures. So this is the post processing machines. It will do remove the unwanted things, and after finally we will take the implant. So how you can check how the model is taken and converted into the 3D printer model, right? Also we can go with virtual planning. Nowadays the doctors will do the robotic surgery, for which somebody will do the surgery consultant with the US doctor or UK doctors. It is possible. That is the virtual planning, and also this kind of the surgery and the implant replacement. And this is actually the how the 3D printed plum implant is fixed in actual person, right? Now extend this application to the prosthetics. It is also perfectly matched with the human anatomy. Somebody by birth they don't have the hand, leg like this. Somebody has some accidents. At the times we can go with some prosthetics kind of thing. Then cranial helmet for needed children's or accident cases. We will have some kind of helmet. We will do. And the 3D printing hearing aids. It's also possible. We will create some mold kind of thing. Then we can make multiple numbers of this. And also for surgery applications, we go with for doing some drilling. So we want to make some surgical guides for doing the operations. Then also used for the pre-surgical planning. And this is the 3D printer heart model, how the process flow, the input may be the model, maybe the CD scan, MRI or PET, then this is the CAD model, then this is the bioprinter, then the printed model we do for surgical plan. Spine also, spinal cord also we can use by using this FDM printer. So you can use suitable material. And another latest development is bioprinting technology. Here the these techniques to combine cells, growth factors, and biomaterials to fabricate the biocritical parts, right? It reduces the dependency and the short supply in the organ donor market. This gives the idea about the bioprinting, how the bioprinting. Here the input is the phone in. We will make the cell, then we will create these bone structures. Similarly, we go with 3D printed skin. Some accident happen, some we go with the skin or some other things. Now we move into the important applications, that is the construction industries, how the 3D printing industry uses this for construction applications. WASP, WASP, that is the one Italian company, they have prototype model, they manufactured these projects within 10 days. Also, this the 3D printed applications. Our army peoples in India, G plus building, G plus owner by using this 3D printer for army applications. Indian Army. So how this large scaled, they will manufactured in on place and transferred, and they will be placed suitably. Then the construction is done by using the cranes. This is one of the applications of the 3D printing for making this. Another applications here in construction wheels. This the in IIT Madras, another one startup company. They have done within 21 days. They have constructed this house. This is the actual design and development of the design.
Sir, I think again there is some network issue, sir.
Now I come back, sir. This is in 3D printing in gel applications. Normally, they use the lost wax casting for making these patterns. Now, the 3D printing technology is useful for the jewelry designers to create the digital design, new kind of design, very quickly create the different kind of models in jewelry industries applications. Please see here,
Sir, your presentation is not visible.
sir.
Sir, your presentation, we could not see your presentation, sir.
Okay, okay. I
Yes.
will. Yes, sir. Yes, sir. Yes, sir. Now it's okay, sir.
Yes, sir. Yes, sir.
Now we find the in jewelry applications. We find this particular technology. How the new designs will be done. This is the TLP kind of printer. TLP kind of printer. Every jewelry makers they have this kind of 3D printer for doing these new designs. We can see this. This the DLP, digital light processing process. Here, these are the models printed here. We will take as the max model. So after removing the support structures, everything, then we go with the traditional process for making jewels. So this is the way the 3D printing is useful in jewelry industries for creating the new models, new designs, and all, right? Lot of new variety of designs we will make. Then food industry, it's also very important here. So how the 3D printed food, we will make the chocolates, cake, right? Pasta, pizzas, all those things. And currently NASA is also explaining they, these things for making for the scientists, right? For astronomists, so space scientists. So this is the way we can see here a lot of different kind of designs we go with the food printing. Now we have this
And
one
now
video
the news
here.
for all
You
those who
have
love dosas.
one startup again by Chennai people. They have this dosa maker. It is
You can now print crispy
we see
dosas by the
here.
push of a button. Fill the cartridge with batter. The machine will roll out dosas in a few minutes. Sam Daniel spoke to the founder of this startup.
How about a dosa printer that would literally eject dosas by a push of a button? Well, that's a real business center. Evo Shakti dosas by a push of a button. Thank you so much for your time and how traditional to do this. So we thought
We
of
can able
making
to
it easy.
vary the thickness of the dosas, and we can change the cooking time. Simple pressing operations, we will make different kind of dosas,
and variety
right?
dosas like garlic and other varieties in this wheat based. And it has been very minimally designed, like within a touch of button you can vary the things of. So now things for domestic as well as HoReCa segments.
This is the Chennai startups. So we find a lot of scope in developing the new kind of this kind of machines. This machine is approximately 14,500. We will also go with for making chapati or idli or some other options also available. As engineer, we will also think on this, developing new kind of ink, food ink, that is the material or cartridge used for this particular
In India,
applications.
yeah, this product technology, everything is as the designers since we are planning for India. But we are
Right.
just to have a capacity to make around 15 to 20,000 pieces at a time, and certainly kitchen automation on a new high. In Chennai with Suresh, Sam Daniel.
And now
Similarly, the one fooding, that is the one restaurant. Here, all food items are 3D printed. This kind of restaurant will come to our place as well. Already it is in Western countries. They have Singapore also have this restaurant. In future, we expect this kind of thing in our India as well, right? Our country as well. So, automotive sector, how why 3D printing is used in automotive? We can make or reduce the time, and also we can use the one concept called the generative design or topology optimizations, and make these 8 components you can integrate into one part and make 40% lighter, 20% stronger. So these are the some ideas using in automotive. And here these engine parts, 80 parts integrated in cylinder plug, 45 parts integrated in cylinder head. So how much weight is reduced, right? So the same engine, this is the Euro 6 engine, has 841 parts left side. The same engine reduced to 200 parts with help of the metal 3D printing. This is the another scope in automotive sectors. Similarly, we have this fully 3D printed engine. This particular all the except bearings and additional components, all other things are 3D printed. This is the world first fully 3D printed e motorbike. You can put this near a bike, you will get some details, and bicycles design we will do, and the wheel rim it's also done. The application used for the creating the miniatures and used in some musical applications, musical components and fashion industries. And nowadays we can use 3D print for making these
how to create your first swatch using the infill method. Like
how
conventional
we
textiles.
fabric or
Most of the
print
fabrics we use in clothing have a structure
3D
made of threads that
printed
are woven or knit
fabric,
together,
right?
like you can see here. But in the case of 3D printed fabrics, this is a bit different because the structure we create resembles a traditional textile, but there are no individual threads, so to speak. This one you see here is created using the infill method, but more on that later. The reason that 3D printed fabrics are so interesting is that you can get all the possibilities that come with digital fabrication, like production on demand, low waste, and this customization, and apply them to creating garments and accessories. So, for example, put their names in the I'll put a couple of them in the description. There is also the possibility of, hey, I'm Sarah.
I'm audible, sir?
Yes, sir. Yes, sir. Yes.
Hello.
Yes. Yes.
Yes. So we these the some applications related to the furniture, home and office accessories, phone stand, and camera, then household appliances. So thank you, friends, for your kind attentions, because a lot of disturbance due to the network is here. So thank you so much for the opportunity given by the Dr.M.G.R. Education and the Research Institute, Madurai. Special thanks to the mechanical department, HOD, faculty members, and the coordinator, Dr. Vijay.R sir, for providing this opportunity. Thank you, sir. Happy 3D printing.
Thank you so much, sir.
Yes, sir.
Yeah. So you took us all, through a journey of on the application of 3D printing, sir. It was an elaborate and well explained lecture, and hope everybody would have understood this thoroughly, and it really made a meaning to all who have attended this FDP. And amid your busy schedule and packed schedule, you spared 1.5 to 2 hours for us. We thank you from our department and from our college, sir. So you took us through the various applications like of construction industry, food industry, automotive, then again musical industry, direct parts and fabric manufacturing, and including hearing aids, and particularly medical area. That was really an eye opener, and a lot of informative things to all of us. And dear panelists, as from the panel side, we, if at all participants, if you have any questions, you can put forth in the chat box, and the feedback link is also shared with you. And you can we understand, like the feedback doesn't work with mobile phones. You just copy it and open in your laptop or your computer. That will be through which you can send your feedback, and in turn your attendance. You can post your attendance for the day. And if your picture is worth 1,000 words, a prototype is worth 1,000 pictures. So 3D printing,
yes, sir,
very much help us in developing the 3D printing, sir. Elaborate explanation, and so a lot of information, and you have brought together, and you shared with us, sir. From the bottom of our heart, we thank you so much. On behalf of Dr. K.R. Vijay.R sir and Professor Jay Silan, on behalf of Dr. Vijay.R sir, we thank you personally, and for making your time. And thank you so much, sir. Once again, we thank all the participants. See you all tomorrow. Tomorrow for the 4th day of our FDP, sharp at 10 a.m. tomorrow. Thank you. Thank you. God bless you all. Thank you. Thank you, sir. Thank you. Thank you.
Thank you, sir. Thank you so much.
Thank you. Thank you, sir.